The UK is facing, like many countries, a series of energy challenges around climate change, energy affordability and energy security, and the project's trying to help contribute to understanding how those challenges might be addressed.
What our project's seeking to do is to rise to the challenge of decarbonising the UK, while also ensuring that we keep the security of supply or the lack of power cuts which the customers require, and also keep the bills down. We've now got over 10,000 customers involved in the trials, and we've got the network technology out there and working.
The technologies that we're trialling are real-time thermal rating on overhead lines, underground cables and on transformers, electrical energy storage at primary substations and distribution substations, and enhanced voltage control across all voltages on our network. On electrical energy storage, we've gone through our specification phase with EA Technology, our technology partner, and we've run that tender process with our colleagues in procurement in pretty much record time.
Thousands of customers have contributed their data for analysis here at the university. We have over 5,000 smart meter records, and we've visited over 100 customers on a face-to-face basis.
The other interesting learning coming out from domestic customers is their appetite for taking on smart technology. The customers who've said that they'll use their smart meter to move and understand where their load is and move it off the evening peak periods for savings in their electricity bills. On the customer trials, we've now got over 1,000 customers involved in our active trials. This is where we're actually asking customers to do things differently with their use of electricity. Can people move into the cheaper nighttime rate off the expensive evening rate, and see if they will be prepared to flex their electricity and save money as a result? We're finding on the industrial and commercial customers there's a lot more appetite for doing demand-side response or moving load out of peak periods for us. This means that we do expect in the next 10 years to potentially be making commercial deals with customers to move their load away from our peak periods as an alternative to network reinforcement.
So the key achievement, I think, so far from this project is that we've really shown with credible results on trials and in simulation and emulation that flexibility and the involvement of customers really can solve today's and the future's network problems.
Some of the key achievements have been disseminating the initial findings from the research to international audiences in Europe and the States, as well as to the British policy audience and industry partners.
The key priority for us is to roll out the trials themselves and pull together both the network technology aspects and the customer trials to see how they each work most effectively in which circumstances.
And next year the real focus is going to be making the most out of the data we've collected, feeding that back to the customer and trying to add some value back to the customer on the trials.
The next stage in our activity is to conduct our winter fieldwork. We've already conducted over 100 interviews over the summer and surveyed customers, but over the winter we'll be going back out to visit them and see how the different heating and lighting requirements and their experience of the propositions has changed their energy use.
We've got some of the final pieces of the network technology being installed, such as the energy storage devices. We've also got our supervisory control system that is going to integrate all the technical interventions together, and that's going to be very interesting to see how that works. And then we've got a lot of real hard thinking and analytical work to do about all the results from the trials. And then finally we say, okay, what are the really key lessons and how do we embed them into future DNO practice? Distribution networks are going to change from being networks that are passively operated to things that are being actively managed in real time, and they're going to become really part of an integrated system rather than the network in isolation. They're going to be managed for flexibility to avoid traditional network reinforcement, and through all of that and involving customers, they're going to enable the low carbon transition. And this project teaches us exactly how to do that in an economic, technically feasible, socially acceptable manner.